All right, it's 5 p.m. Time for the last session, and I figured like if you want to stay awake for this one last session, or if you want to drop out, we can do a drinking game where every time I say assembly load context. So you might be familiar with this error message or this one. Raise of hands, who's seen this? Majority of the rooms. They're more familiar in red. So before we get into it, I'd like to throw a huge thank you to all our sponsors making this event happen. It's just fantastic, and it's been so much fun this year. So many great sessions, so many great people. So thank you for everyone, to everyone who's being part of this and making it happen. My name is Emanuel Palm. I work at Knowledge Factory at Albania, Sweden, and I love code. I've been working with PowerShell and .NET for many years. C# was one of my first real programming languages, and I found PowerShell because of it. And now I'm kind of finding myself somewhere between the two languages. I am event-driven, so I come out to places to speak. That's fun. I make modules and tools, and most of them are open source on my GitHub, which you can find down below at Palm Emanuel. I also have a blog at pipe.how, where I have written on this thing. So if you go to pipe.how/get-assembly-load-context, you can find that post. It's a couple of years old, and what we're talking about today is not the same pattern, although I will touch upon it. I also play Dungeons & Dragons. I love baking. I'm a coffee nerd. I do bouldering, and I play frisbee golf in the summers. Reach me here. First of all, this session is not about app domains. It's not about .NET Framework, and it's not about Windows PowerShell 5.1. Assembly load contexts are not in any of these, and these are concepts that will work, or these are concepts that are not relevant to these technologies. So if you're working with lower PowerShell versions, you won't be able to use assembly load contexts. What we are talking about is assemblies. We are talking about .NET, previously known as .NET Core, and we are talking about PowerShell 7 and up. Technically 6 and up, as Andy mentioned in their great talk just previously. And if you are working with PowerShell 6, you should probably upgrade, though. So assembly load context. I might be saying ALCs sometimes. You might see them on the slides. The same thing. I just don't always want to make you drink. We have 3 facts to start with. There's always a default assembly load context used in .NET applications. PowerShell is a .NET application. PowerShell loads everything into the default ALC. And thirdly, each ALC can only hold one version of any named assembly. And these last 2 form a crux. This is the kind of root of our issue, right? We can only have one version of any assembly in the default context, which PowerShell loads everything into. So our logical answer is maybe we should create our own contexts. And that's why we're here. PowerShell, let's make a graphical example here. We have a session running, and we import a module called parseJWT, which I wrote. We're going to demo it later. And this is a module with a quick example to parse tokens, like access tokens in Azure. And they actually hold a lot of data about what you're accessing and the scopes and the things. So they're encoded and they're a little bit wonky to do yourself. So why not use someone else's library to do this, right? Why not use functionality that's out there that someone has written and that's tested and that's kind of official from Microsoft even, to parse these things and get the data, get the scopes and the issuer and the account and everything. And that works great. It's super good. And we have a module. We can do this in PowerShell. We can use the assembly types immediately, or we can use it in a root module, in a binary module in C#. And that's a little bit easier to work with NuGet packages and libraries. If you were here yesterday, me and Justin gave a talk on that. And in the same session, we might be loading Microsoft Graph, like a common module to work with things that require tokens for example, could be another module. But as an example, this one also uses the same assembly, same library, but with a different version, lower one, because I happen to be just making a new module. Everyone isn't up to date all the time, and that is an issue. So when PowerShell loads everything into the default assembly load context, we have a conflict, because these two versions can't coexist. Actually, no two assemblies of the same name can coexist. And if it was just the same version, it would load that one. So that would be fine. Small disclaimer here before I throw too much shade at Graph is that they have an assembly load context implemented. They just haven't released that version yet, at least as of writing this demo. So it's on preview, I think. And more of these official Microsoft modules, community modules, are implementing ALCs to solve or postpone or band-aid, depending on if you ask me or Andy, this issue. Because it's solved for that module, but it's a lot of work. And it's not always a convenient solution. This is only made worse by PowerShell itself having more assemblies. Andy here mentioned, I think, 70 packages just for PowerShell. There's a decent risk that PowerShell itself is using popular, well-maintained packages like we want to do as well. So our solution is to move this to our own custom ALC. We move our module, we move all of our dependencies over here into a box that we can control and make sure that nothing else gets loaded and there won't be any conflicts. And that's kind of the gist of this talk. To do this, we have 3 steps. We need to create our own assembly load context. We need to hide assemblies from PowerShell, because if PowerShell finds them, it will load them and it will break everything. So it's going to load them into the default ALC, and we may need to make sure that PowerShell does not find our assemblies. So we need to hide them. But if we hide them, PowerShell can't load them. So how do we load them? We need to override the logic and inject some custom loading logic to make sure that we can resolve our assemblies either before PowerShell gets the option to, or yeah, that's pretty much the gist of it. There are, many different versions of modules. They can be script modules, PSM1 files. They can be binary modules, C#, F#, VB. Or they could be hybrid. So we could have one that uses both commandlets from C# and functions written in PSM1 files, or just script files that get compiled into a nice build. We've seen a lot of examples this year of great tools for that. And to do this, we need to match these various ways of writing modules with what works for us. And with this, we have a few patterns for writing assembly load context solutions, which kind of involve a resolver with the logic that we talked about. First of all, Andy mentioned it, and I don't remember where we started calling it that, if it was Rob from the previous PowerShell team, or previously on the PowerShell team, named it a bridge module, which includes, let's make another example here, a PowerShell session loading our module, which in turn is loading a kind of part module. This one is going to be an example of a root module in our manifest, for example, which is part of a project in C#. So it would be written in binary, a binary module, and this could work for a script module as well, but it's just for the sake of it here. We need this one to have all of our commandlets, but it can't access any of our dependency logic, because then PowerShell gets to know about it. We can't have that, so we have to kind of isolate these two. So then we build what's in the blog post from Rob, known as the engine project. In one of our hobby projects that we also talked about, me and Simon here, on Monday, called PS Bicep, we utilized this pattern to load something called Bicep Net, which has a PS assembly with all our commandlets and a core assembly with all dependencies and all logic, making sure that we don't leak any types or anything from that core assembly, or the engine assembly, depending on what we talk about, what we name it. So the idea here is that the PowerShell module, the PS module here, is also the resolver and the ALC creator, so that when we load that module, it takes care of loading all its dependencies into its own ALC. And that kind of works. That's the most robust solution. It's also the most complicated to write. As Andy talked about, we pretty much have to rewrite the entire module to make that work if we have an existing module, because that's suddenly you can't access the types you're sending out from your commandlets. You can't give those to the user anymore. You can make models of them in your core assembly, just make sure that they never overlap or reference each other, and it's really complex. So if you stick to strings and ints, that's great, but sometimes you're not. The other pattern, which I've decided to split into two examples, is something that's enabled by a pull request, or an RFC actually, made last year by the PowerShell team in February or so. So it's been around for a while. It's also what Andy demoed at the end, although I'm going to show a different way. And this one, also PowerShell session imports our module, which points at the DLL file, which is only the resolver. So we implement a specific piece of logic to resolve our other assemblies in C#. And this one we put together with our module somewhere, and we reference it in our manifest in a specific location that we're going to take a look at later in the nested modules. And then we also reference our root module, maybe a C# module in this case, a DLL file that we put in, in the root module. And we do that in the manifest, and this looks good. But what's happening here is actually that the nested modules get processed earlier, and us setting up a resolver lets us override or kind of intercept the loading logic of PowerShell. So our resolver is going to take those dependencies that we asked for and take those into our own ALC. Finally, a script version of the same module would look something like this. So we have our PowerShell session importing our PSD1 file, our manifest, which sets up the resolver, points at the blue ones, mostly blue if you can see that, are the ones that contain the commandlets or functions for our module. It's what we would call our module in this case. So we have a script module on the side, which could be the root module, and then we have the resolver on the side, which is referred to in the nested modules. And then we have all the dependencies, which can actually be loaded in loads of ways, which is part of the problem here. So we can actually have them in 3 different ways in the manifest. We can load them during runtime. We can load them in our commandlets. We can load them with a bunch of different ways. But by setting up the resolver, whenever we have a load, whenever we load an assembly, the resolver is going to intercept here, and it's going to load it into our custom ALC, even if it's a script module kind of at the base of it. So it doesn't really matter if it's a C# module, hybrid module, script module. The resolver works in the same way, and this one is the one we're going to write today. But before that, I want you to join me for a far-fetched analogy. Think of us as Santa. It's Christmas, and PowerShell is a child. Christmas, by the way, is this holiday where we give children presents. So the child will try to find all the presents, right? And when we import our module, it's going to know about the presents. We've told them that there are presents somewhere, and it's going to look under this tree, because that's traditionally where we place them. But we have hidden them away in the wardrobe, so the PowerShell will come to us and ask, I really want that Lego set, you know? You've mentioned it, but where is it? Well, we say, you can't actually open it yet because it's the 22nd, and you would rip it apart and load it into the default context. So we hide them away, and then when it's time for opening the gifts, we do it under our conditions into our own loading context and kind of make sure that PowerShell doesn't ruin everything. And then finally, I just wanted a snowman. So for this to work, we have 3 pieces of code. 2 of them, or I should say kind of the first bullet point here, showing 2 interfaces in C#, called iModule assembly initializer and the cleanup. They are allowing us to run the code when import module is run on our assembly or our module kind of pointing at our assembly, and when we run remove module for the cleanup. This means that we can run code and set up stuff before everything is processed in our import kind of process. And it lets us run and set up resolving code that we can then use to intercept the loading logic of our assemblies. And this is a reference to the default assembly load context. It has a static property to reach or reference the default one, so you can always kind of look at it. And that one has an event called resolving, where we can set up our handler. And finally, Andy mentioned there are endless amounts of ways to load assemblies, and there are. So which one do we use? I have a not complex table for you to look at that will make it clear. So we won't touch on all of these, but the issue is basically that we can load them with the assembly type, which sometimes lets PowerShell know about them and sometimes doesn't. I think actually it does always do that from the assembly type. But sometimes it puts them into a new ALC, which is good. And sometimes it puts them into the default ALC, which is, in this case, not good. But they are always discoverable by PowerShell. So if we have types in there and we load types in another ALC, those types will not be considered the same by .NET, because types are considered the same only if they come from the same assembly load context. What we don't want to do instead is to take our custom assembly load context and use load from assembly name and load from assembly path. Loading from assembly name on our assembly load context will trigger a full resolution. So we will find all the files that we've, it will let us load based on whatever criteria we set, basically. And then finally, we want to load it by path, which is what we're going to do in the code in a little bit. And then we have more load from stream, load from, yeah, you get the point. There's an issue here. There's a lot of ways and lots of opportunities to step the wrong way. Finally, there are 3 steps in the manifest where we can load assemblies, basically. First of all, we have required modules. This one is the first processed, and it's actually too early for us to set up our resolving handler. So if we do anything here, it won't. It's too early, so we can't really process our logic here. In the nested modules, however, this is actually happening before the root module. So what we can do in our isolated pattern is to set up a resolver, and then even if it's a lot of other assemblies, all of those are going to be intercepted in terms of logic for loading, so we can make sure that none of our other assemblies are loaded into the default one. And this is because import module is run on all modules in the nested modules, and it's run on the root module. And import module is the thing that lets us use the iModule assembly initializer, which lets us run code when we load our module. So let's have a demo. Let's do some live coding. See if I can swap over. And I'm going to use Visual Studio for this, and not Visual Studio Code like we did yesterday in our follow-along session. And the reason for that is simply that I am more used to it. So this is our one commandlet that I talked about earlier. This is a commandlet called getTokenInfo. We have the commandlet up here. We have a verb called get, and we have a tokeninfo as the noun. It takes one parameter that's mandatory, and in the end processing block, which should maybe have been process record, I'm not sure, we use this system identity model tokens JWT library to parse our JWT token. And then we write output. So it's going to write this whole thing, which will be a JWT security token type from our assembly here from the library. So if we jump in here, I'm going to zoom a little bit for you. I haven't made this white, so I hope that works. So first of all, let's publish our project. And this will take all of our dependencies and everything and put them in a nice catalog so that we can import them. And if we run import module on this long path, bin debug .NET 6 publish parseJWT DLL with the verbose, we can see that we imported our token. Sorry, our command and our module, of course. So this is pointing directly at the root module that we would have in our manifest. It's pointing directly at the binary module, the DLL file. So we have no manifest, we have no metadata, we're just importing the commandlet. And if we run getTokenInfo with a token that I've prepared, we get some information. This is not secret. It's a token from OWASP. It's username administrator is admin true. It's just for the format to try to work. And that works. So we can also have a look at assembly load context stuff. So if we use the system runtime loader assembly load context and use the static property all on that, we can have a look at all the assemblies and filter where the full name is something like system identity model tokens JWT star and select everything. And this lets us see all the information about the assembly that matches this. So this is letting us see which assembly we've loaded. So we have the 6.31 version we can see here. And we see that it's basically loaded. And we can also see, if we do this, we changed it all to default. It's in the default assembly load context because we haven't built any fancy assembly loading logic for it. So that's great. And now I'm going to import Microsoft Graph authentication for a certain version that worked for the demo because I was worried they were going to fix it. And then we connect Graph. And it says, welcome to Graph. Everything's great. Everything's working. So that's great. And then the other day, the next day, maybe I'll have a coffee, I go home, I don't know. I'm working, and then I do it differently. So if we zoom in here, a little bit more. Oops. Here we go. Port module, Microsoft Graph authentication. We do that. And then again, we connect to Graph like we do every morning, maybe. And then we import our new module that we built. Perfect for parsing our tokens. We throw on the verbose there. And then we run the getTokenInfo with our token, and it's red because we did it in the wrong order. And the end user will never realize this. It's a very strange phenomenon, obviously, and we're going to fix it. That's why we're here. But before we're here, I'm just going to show the same thing. So we take all assembly load contexts, .assemblies to get all of them, and then filter here. There are some different ways of doing that, but just to get all the information for you, you can see them here. We can see that the version now is not 6.31, it's 5.6, because that's the one that was loaded by Graph. And when we load our newer one, it will find it, try to load the newer one, and realize that it can't, because it's already loaded. Differently, before it worked, because it was a higher version. So let's do some coding. In here, I have prepared another part of the solution. So I have here, is it large enough for you, by the way, in the back? Yeah, awesome. I have a file called module isolation where I want to implement two pieces of code. I want the assembly load context, and I prepared some comments here for myself so I don't forget, and the module initializer, which will implement these iModule assembly initializer stuff. So let's start with this. Create a class called parseJWT assembly load context, because we might as well make it like a personal implementation for our module, which inherits from assembly load context. Then we want to create a private string. We can make it, I think, like that. Yeah. Dependency directory, which we will store the directory in which our dependencies are loaded to, or put in, loaded from. Then we want a constructor So the constructor is the piece of code that is run when our class is initialized or when an object is created of this class, which is public parseJWT assembly load context, which is the type. And then, I don't know, it gave me some suggestion there. We take a path, which is going to be the path that we try to resolve our dependencies from. And then we call the base with a name so that when we load our the ALC, it's going to have a name. Otherwise, it won't. And then we say dependency directory equals the path that we give it. Not too complicated. Finally, we have to implement one more thing. Protected override assembly load. And this lets us override the loading logic of our assembly load context so that we will change the way that .NET kind of resolves this when using our assembly load context. Here we have a few, well, one mainly. We have a name of our assembly. And then we want to assemble a path. So we take path.join with our dependency directory. And then we use some fancy string interpolation with this name.dll. So we will then check if it exists, this new path that we've assembled. We're going to return load from assembly path with this assembly path. And then if it doesn't exist, we're going to return null so that the next, I don't want to say person because it's not a person, but the next registered resolver gets an opportunity to load this. I can just fix this indentation as well. Oops. And this is part of the stuff done. So we have our loading logic. We will try to load it from a specific directory that we haven't yet implemented. So let's do that. Down here, we can make a second class, which I like calling something like module initializer. In this case, note that it doesn't have to be the same as the file name, which is module isolation. If you can see that small, it's a bit smaller. And here we implement the iModule assembly initializer and the iModule assembly cleanup so that we can register code on import and remove. And one of the reasons why I like Visual Studio is that it has stuff like this. So I can quick action and just implement the interface. And it won't give me actual code that's useful, but I can at least remember how they look. In this case, when we import it, we want to run a specific piece of code that is assembly load context, .default. This is the reference we were talking about, and this is the resolving event. So we want to subscribe to this event with resolve assembly. This is a method that we're going to implement in a moment. So we have added a subscription, you could say, and we want to do the same to make sure that if our user removes this, we're not going to try to continue resolving it this way. So we use a minus equals here. And then finally, we also want some variables, I think, just to make sure that we have the dependency directory. And we want to use the directory name of the current executing assembly.location. So we get wherever this assembly is placed. And this is a neat way for me to be able to drag and drop it into any folder and then just point at it in the manifest, which we're going to see. And then one more thing to actually create the assembly load context that we have made. And it takes a path, right? So we use this path when we say new. This is shorthand saying of new parseJWT assembly load context. And then finally, there's only one more thing to do, which is to implement the resolve assembly here. So let's do that. We want a assembly. The question mark here means nullable. And then we call it resolve assembly like we did above so that it's happy, matches. We take two things here. We take the assembly load context, which is going to be the default. We know this because it's the only one we've registered for. So there's no other assembly load context that we'll try to do, like call our method here. So we always know that we can use that one. And then the name of the assembly that it's going to try to resolve. Now we check if this assembly name, .name, because it's a property on this class called assembly name, equals parseJWT, because we don't want to resolve a lot of other stuff. There are weird cases here where if we don't try to specify this, we're going to try to resolve like everything that's being sent here, and we can end up in like recursion stuff that just gives a Stack Overflow. So we want to be very precise when implementing ALCs, like Andy was talking about, and it's part of the issue why it's like so complex. But hopefully by the end of this session, you will have some more tools on how to do this. So we take the ALC here, which is our custom one on line, I don't have a line number, but where my mouse is, we call it ALC. We say load from assembly name. So this will trigger the full resolution so that in there we can use load from assembly path. And then we give it a name, which it's going to use to assemble this from the directory plus DLL. And then finally, same thing. If we don't find it, or if it doesn't match, we just return null so that PowerShell doesn't crash, and that's so that someone else can get the opportunity to load this assembly that has been requested. So we'll save this, and this is actually everything that's needed for the kind of isolated module pattern. If you want to use the bridge pattern, which is more robust, you will have to do more work. You will have to make more projects, and you will have to split your logic and all your commandlets and make sure that nothing gets leaked in terms of types or referenced. And I didn't have time in 45 minutes to make that demo here. So hopefully this will give you kind of a starter understanding of what to do and why we can hopefully solve it for our own modules, at least. So let's jump back here to demo number 3. I think I have the first command to build it. So I prepared a small build script, which is actually useful here because now we want to have our manifest somewhere, and then we want the dependencies folder and put all our dependencies there, because if we keep our assemblies together with our manifest, PowerShell is going to know about them and it's going to load them. So we need to hide them away, right? And then we can do that in a directory called dependencies. So if we actually just go here, we can see a little bit how that looks. It's a bit small, but you have one file called parseJWT. It's a PSD1 file. It's a manifest file. And in here, we have all the assemblies that I've actually moved here in the build script. So the build script basically runs .NET Publish and moves stuff here. That's it. And you can make them super complex, right? You can do just what you need in terms of your file structure and your modules. That's how that looks. So let's try it. Let's try importing graph again, because that's the order that was colliding, right? The conflicts. And then we connect it to graph. So we know that at this point we have loaded our assemblies, because we have both loaded the module, and if it wasn't enough, we have also run a command from it that at least I know is enough. And that varies, which is also part of the complexity. Sometimes the assemblies are loaded when you import a module. Sometimes they're loaded when the first command is run or when a specific command is run. And what do you think will happen now? It's going to work. So to demonstrate here, we can also get token info, because that's actually when it broke last time. We can see that it's working. So diving into this a little bit again, we go to assembly load context, all, .assemblies, where object, full name, like system, identity model, tokens, JWT star, select everything. And before we select everything, actually, let's measure. Just check here. We have 2 of them. So now we have 2 assemblies amongst all our assembly load context with the same full name, or at least mostly the same name. I know they're the same. Where if we scroll up, we have 1 with 631 from our module. And if we scroll up further, we have 5.6. And just to do a little bit like this, assembly load context, : all, hype, percentage name. we can see that we have 3 of them, and I'll explain the middle one. But we have a default, and we have the parseJWT context that we created. The middle one is actually from Graph, doing some weird stuff with load file. So that's another example of the loading logic and all these methods and stuff actually doing weird stuff. So some of them, as I mentioned in the table, actually have functionality to create their own new assembly load context just for this file, which can be helpful, I guess, sometimes, but it's not very controlled. So now we have 3. But this one is not for the same DLL, so it's not really relevant to the demo or anything. It's not the JWT one. So that's number 3. But can we make it faster, smoother, and simpler? Has been my question since I read this RFC. So I've been thinking, couldn't we make like a dynamic way of, if we already have, let's look at this. We have in the out folder, we have our manifest. And all we really did, let's look at it, is put this as the first element. I'll zoom and remove this and this. There you go. We've cleaned it up. So we have number 1, 2, 3. We have the required assemblies, which we don't use because it's before the resolver. We have number 2, which is the nested modules, where we hook up our resolvers so that the root module can be resolved by our own logic. The root module here, if you notice, is not pointing to dependencies, /dependency/root module, or parseJWT, even though that's where it resides. But for our logic, the module isolation DLL, that's actually relatively the same path. So that's why that works. If you run test module manifest on this, it's not going to work, because this is no valid manifest in that sense anymore, because PowerShell tries to import it, and, well, maybe this one is, but sometimes it isn't, depending on where you have your assemblies. So it's harder to debug as well. But the only thing we did was put it here, and then we have a fairly general implementation here. So what if we wrote the module to do that, is something I'd been thinking for a while. So me and Simon, after the community dinner last night, decided to get coding. So we have a 4th demo. Yeah, after the party. Of course. That's when the best code is run and written. So what happens? We just rebuild it. Sorry, we can't do that because the DLL is locked. Also a problem with binary module development. If you import the assembly, there is no unimporting this assembly, and you have to cancel. Well, whoops. Yeah, that's fine. I had something open that was killed. So let's just run it one more time to make sure it's fine. So we check again. Just have a look at the dependencies folder. What if we just, because I'm lazy, we remove this module isolation stuff. We go back to kind of the way that we had set this up. Just clear this out. So this would trigger a conflict, right? We no longer have our resolver. What if we had a command to solve this? What if we had a module called isolate? So me and Simon, we wrote a module called isol8 with an 8, because that's cool, which you can install right now. It's a little bit experimental, I would say, still. I think I pushed the 5th version here, maybe. Let's have a look at it. No, 4th version. 2 hours ago. Just stressful enough for the demo to work for my session. And all we need to do for this to implement this pattern that I talked about during this session that we coded together is to run one piece of code, new isol8 assembly. We give it a name, which would be, in this case, parseJWT. It's the module name. This is inserted into some kind of on-the-fly C# that we're then importing and compiling. We have a manifest path, which is out parseJWT to the manifest path. And then we have a path to where we want to drop this assembly. This will be the dependencies folder. So we're just going to write this out, C code, assembly, concept, and then dependencies. And then we can name it pretty much everything. So name it my new cool resolver assembly.dll. And what happened? Well, I haven't written any cool output yet. I didn't have time for that. So, wow, look at that. Line 14 was updated in the manifest. So we've actually updated the manifest that we pointed to with a reference to the DLL that we also created called my new cool resolver assembly. So this will hopefully make it easier to implement a simple ALC version. And we can then have a look at this practical conflict thing again and see if it works. So we import that, we connect graph, everything's happy. We import module by manifest with the verbose. We see that it imports the token info stuff. Get token info, token. It just works. If we run it again, the loader assembly load context, all assemblies pipe where object full name like system identity model tokens JWT star, select everything. We can see that it should produce the same thing, right? It should behave like that one. We just made it a general solution. We have version 6.31 and we have version 5.6. To summarize, before we wrap up for a couple of questions, we have a couple of minutes left. We have a fairly complex topic. So this is a general solution for some cases, like the cases where you don't have super complex structures and a lot of dependencies and a lot of things. It's for the cases where your module can maybe put all of your dependencies in another folder and then just resolve them from that. And if that works for you, we made it easier. If that doesn't work for you, we're still in the same problem together. So hopefully that can help. But otherwise, modules and requirements are different. We may have to implement the full bridge module thing. We may have to separate all the things and all the references and make sure that no types are leaking from our dependencies. And even then, what works now may break in the future because someone else might upgrade to a higher version and break something that's working right now, or you might be upgrading or whatever. All these mismatches, even if it's the same version now, it probably won't be in 2 years. So if I have a module that's working really well with Azure PowerShell now, Azure PowerShell is a bad example because they implemented ALC mostly. A popular module, not to be named. It might not work in the future. To finish off, I just want to mention that I put a ton of links in my slides. So if you're curious about reading more on this, I put pretty much all my research, all my blog post, and all the RFC stuff in there as well in the notes of this particular last slide, as well as some comments and other ones for you to browse through them. With that, are there any questions? Yeah. Yeah, so the question is it enough in my build script to add new isolate assembly as a command after .NET publish or .NET build and such? And yes, that's the idea. You should be able to take that general thing and just put it in with your dependencies after building your module. And make sure to move the dependencies to a folder where you place this one. Because right now, come with feedback, open issues with it's an open source module, so see what's working, what's not working. It's very much an experiment right now, so if it works, great. If you have feature requests, come with them. So right now, you can't really specify any other location if you want that. Put an issue. More questions? Do I know what prompted the .NET team to implement assembly load context? No. Andy, do you know? Yeah. No. Comment was that it might have just come from the general need of isolating assemblies from each other. Because app domains has that functionality-ish, but not really in the same way. So it's a lot of different concepts when working with .NET Framework. So moving to core, they probably wanted to improve that. And I would say it has been improved, but it has not been resolved. More questions? Yeah, one more. Yeah, have I tried the new C# DevKit extension in VS Code? Yes, I have. It's fantastic, and I just didn't want to rebuild my entire demo, which actually uses Stagecoder, which was demoed today in the community demo. So me typing fast and correctly was not actually me typing fast and correctly. Check it out. It's in Visual Studio as well. Thank you, everyone, for coming.